Do you mean the new test or this review?
This test right here, the last test, where I just want to
Yeah.
make sure everyone understands what they missed if they missed it.
Problem number 2,
On test A or B?
C.
2C. On which version of the test did you have?
Oh, gee, I don't know. I don't know.
Okay, so does it look like this problem? 5x plus 3?
Let's see here. 5x plus 3, 9,
Yeah.
5x, yeah, equals 2, 10. So, yeah.
Okay.
I mean, so basically I got to the point where I was at x equals 20x minus 49 over 20. And I already knew it was no solution. So I just stopped there and I just put that this is what the solution is. I crossed out the equal signs. It's no solution. Put a contradiction as the classification. But it says should have no x left. But I just stopped because it was already no solution. So I mean, I guess we just continue to write it out until it's like
Right.
nothing
Yeah,
left. Or
because I mean, at this point, how can you tell there's no solution?
oh well, I don't know. I guess. Wait, I lost you guys. Wait. What? I can't. You're in a little tiny window now. Okay, here it
Huh.
is.
You
I
get
got it.
back?
So, anyways, I mean, to me, it was already obvious that it is because obviously the 20s cancel out, so
No,
you're left with
they don't though. Not in
on the right side,
not like that.
20x divided by 20 is going to be equal x. Okay, so
No,
then
you'd have to divide the 20 into the 9 as well.
no, that's what I'm saying. So it's x minus 9 over 20.
Okay, so that's what you need to keep going even further because at this point you might can see it, but it's not really clear. You need to keep going further than that. So you need to go like you need to come out with a no variable and a pure contradiction with numbers, like 5 equals 7 or something like that. So I shouldn't have, I mean, you shouldn't have lost all your points on that.
Yeah, I don't know. I become confused once we start losing the variables. I'm used to doing it the other way around where everything else is canceled out except for the variables. But this leaving the numbers behind and then getting rid of the variables is just very kind of it seems off to me for some reason. It just
Well,
I don't know. Hard for me to do that.
Yeah. That's really how you know if it's a contradiction is once the variables are gone and you're left with numbers that don't agree.
Let's see.
And you should have
Okay.
definitely gotten most credit for that. Most of the
And see number 3. I don't know if I even wrote the full questions on these. I may have picked it up from. I'm already starting to solve it in my head here, but number 3 I started off with -3 squared plus 5 squared over -3 plus 5.
Okay, so
So I
that's
don't
where
know
you
what that
messed up
was.
on the top. You messed up on the top because it should have been -3 squared minus -5 squared. And so that would be, can you see my screen?
Yeah, let me see here. Oh, yeah, yeah, minus -5 squared, but I already solved the negative signs and
But remember order of
put it into,
operations. So it would have to be, this would be 9 minus 25. Because the order of operations says that you do what's in the parentheses and the exponents before you do any addition and subtraction.
right, but if the squared is outside of the parentheses, doesn't that still leave it as a negative?
No, that makes it
Or is it
positive.
when it's inside?
Right, right. If it's the negatives on the inside of the parentheses, that the square makes it positive. And this one, a whole lot of people missed. I was kind of discouraged on this one.
Yeah, I ended up with -8 in any case.
Yeah. Any other questions, y'all?
Well, wait, it's still, oh, yeah, yeah, that's right. Yeah, actually, no, I answered it +8. So yeah, I was
Uh-huh.
off by the negative. Yeah.
Uh-huh. Yeah, you got to be careful about that.
Okay, if we're plugging in these numbers for the X and the Y, what's the rule that puts them in a parentheses when we're making it squared? I
So
mean, what rule are we applying?
anywhere you have an X or a Y, you're always going to put a parentheses before you put the number in.
Okay, so you automatically put it in parentheses
Yeah,
as soon as you substitute it. Okay.
right. That's a safe way to do it, right?
Ms. Watson,
Yes.
for problems 6B, can you quickly go over and just re-show us how to solve that one, please?
Sure. Yeah, and a lot of people miss this one too. So we have we're solving for H. Now, some of y'all divided by 1/3, and I think I counted off 1 point or something, or 2 points for that. Because if you, I'll show you in a minute, but the way that you really should do this one first, there's several ways you can do it, but you're trying to get this H by itself. So to get rid of a 1/3, you would multiply both sides by 3. So that would give us 3v equals pi r squared times h. And then to get rid of multiplication, because h is being multiplied by both pi and r squared, the reciprocal operation or the inverse operation is division. So you're going to divide both sides by pi r squared. So when you do that, you wind up with h equals 3v over pi r squared. Now, some of y'all, and this is not completely wrong, it's just not completely simplified either, in my opinion. Some of y'all did this. You divided both sides by 1/3 pi r squared. And you got h equals v divided by 1/3 pi r squared. That's really, if you have fractions within fractions, you really should try to make that not happen. So in order to get rid of this 1/3 here on the bottom, you could have multiplied the bottom by 3 and the top by 3. And that would have fixed that problem.
Will there be problems like these on future tests?
Oh yeah, you have to be able to solve for variable for sure.
All right. Let me go ahead and write that down real quick. See if we can see it. Okay, let's take a photo. Okay. Also, Ms. Watson,
Yeah, yes,
also go over problem 10.
10.
Yes, ma'am.
Yes, okay. So if two angles are supplementary, that means they add to 180. So if I'm going to let X be one of the angles, and one of the angles is 15 more than its supplement, so the second angle would be X plus 15. And so if you add the first angle plus the second angle, that would give you 180 degrees. And so we have 2x plus 15 equals 180. So 2x is equal to 165. And so x is going to be 82.5 degrees. And then to find the second angle, you would just add 15 to that. So x plus 15 would be 97.5.
Okay. Still writing this all down.
Yeah, and you can check them too if you want to add those two. Let's see if they add to 180.
For safety measure. Okay.
What a lot of people will do is they'll see that x plus 15, and then they try to make an equation, and they'll just take
Yep.
one angle,
That's what I
that
did.
x plus 15, and they'll make it equal to 180. They'll forget to add the first angle.
That's what I did. I just solved for x. Darn it. Okay. X plus 15 equals 97. Okay. All right, I'm all set. Thank you very much, Ms. Watson.
You're welcome. Any others, you guys? I think y'all mostly did really well on the inequalities. The ones that I saw that most people were having trouble with was 6B and number 3. So, does anyone want to see any of the others before we?
Number 4,
Uh-huh.
I got x equals 2x minus 36 over 5, or is that an S? I think it's a 5. So, but I guess the answer actually is x equals 12, according to this.
Okay, so you didn't finish it, Michael. So you have x's on both sides, right? So how could you get rid of this divide by 5? What would you do to get rid of it?
I don't know. I really couldn't. I didn't know really how to simplify that. 2x divided by 5 is just 2x over 5.
No, but I'm saying, okay, so
I could multiply both sides by 5, but now I've
yeah.
got 5x on one side.
Right, good. Okay, so if you multiplied both sides by 5, that would give us 5x equals 2x minus 36, right?
Right, but wouldn't I have to divide by 5 each side again to get back to x?
Okay, so now you want to get the x's all by themselves on the left, right? Or so how would I get this 2x over onto the other side? That's a positive 2x. And I want to combine it with the 5x on the left.
Subtracted.
So you would subtract it from both sides?
So sometimes you have solutions where the variable isn't even in the solution. Sometimes because you get rid of the variables.
Well, you should always, that should always
But
happen.
I always look at the variables. So I mean, there's a decision sometimes. You can either get rid of the variables or you can get rid of some of the numbers. And I don't know which one way to go sometimes. Like on number, which one was that? Number 2 or?
You're always trying to get the variable isolated. That's the objective.
Right,
is
but in some of these, the variable doesn't, we get rid of the variable. That's what so I'm looking at it like a decision. If I get rid of the variable, doesn't that kind of defeat the purpose of finding the variable?
Well, if you can get rid of the variable, that means that there's either no solution or all real number solutions.
I mean, the goal in general is to get the variable
In
by
some
its.
of these, yeah, but in some problems, it seems like there's a decision where you can get rid of the variable or you can choose not to. And also some of these solutions are complex equations. It's not something as simple as like X or Y equals some number.
It should
So
be.
that's the other thing.
No, it should be as simple as X or Y equals to some number. And if that doesn't happen, then you've got a situation where it's not, it normally in most equations in math, you will come up with X equals something or Y equals something. And if you don't, then that's kind of like it's kind of like a freakish thing to happen. I mean, it's not like it never happens, but it's something that doesn't happen as often. But it does happen, which is why we cover it. That's when you have the identity or the no solution.
Right, like the H equals 3V over pi R squared. I mean,
Mhm.
that's like a complex expression. That's what the variable comes out to.
Yeah, that's when
So,
you're,
I mean, I guess I can just try to continue to simplify it, but what I'm worried about, because this is like a time test, is that I just can't continue to mess with it until, I mean, I guess I can just go on forever, just kind of trying to simplify it. But I have to kind of let it go and just, at some point, just let that be the solution.
right. If you're asked to solve for a variable like H, once you H by itself, then you're through unless you've got like, you can simplify it further on the right. But once you have the H by itself, then that's how you
In
know.
math, I mean, theoretically, you can continue to simplify really anything. I mean, there's really nothing that cannot be simplified in some way.
That's not
Three-
true.
So 3V over pi R squared, I could multiply that by pi R squared and end up with 3V, right? But then I'm gonna have to I'll multiply the H by pi R squared.
Right.
That's what starts to confuse me. Like, well, I mean, at what point
Because
do I
then
stop
the
here?
H wouldn't be by itself, right? Because once you get the H by itself, then you stop.
Yeah, because if you multiply by pi r squared, you wouldn't be solving for h. You'd be making h more complicated.
Mhm.
You'd be putting stuff onto the h, and you're just trying to get h by itself.
On number, let's see. Let me go back here. I'm looking at the PDF here. Okay, so like on number 4, I do have the X by itself, but we continued to simplify it, and which made the X, at least temporarily, more complex. So, that's why I'm saying, and there was a few steps here that I missed, but I think that,
No, you did not have the X by itself because you had this. And you have the X's on both sides, and you don't want that. You want the X all by itself.
Yeah, this is kind of like when
Okay,
you're defining a word, you don't want to use the word in your definition of the word, right?
You can't have it when you're solving an equation. you want the variable to be totally by itself on the left or whatever side you choose, but I always pick it on the left usually, and everything else on the right. And if that doesn't happen, then you're not through.
Okay, so even if it gets rid of the variable, we should continue to solve it. If the variable is on both sides of the equation,
Right.
regardless of whatever, even if the variable goes away.
Yep.
Yep.
Okay, so that's what that makes that one different from number 6B.
Yeah, and I would say like 6B, it's like more of a generalization. They're giving you more variables, and I think the previous one, they're giving you all numbers to plug in, right? And just a single variable. So it is a little bit more complicated, this one.
The main thing you need to, I mean, you need to be able to do this, but like here, this is what you really need to be able to do in this section, because you need to be able to put linear equations into slope-intercept form. And so you have to be able to solve for y, or for the dependent variable. But if you know your algebraic operations, you should be able to solve for any variable, no matter how complex the equation is. That just shows that you know the right order of operations and how to isolate a variable.
Yeah, and I guess if it ends up being some like nonsensical thing where it doesn't even equal itself, then that's just like a no solution answer at
Right.
that point. Yeah, I think I just need to get used, because I start to get like I'm doing something wrong if it's not equaling itself, but sometimes it's not going to. So you just have to, that just has to be a non-solvable, whatever you call it,
Yeah.
contradiction or whatever.
Yes, a contradiction. And we were showing you that, but it doesn't happen that often. It's not something you see most of the time, except for in sections where we're teaching those kinds of things. Although when we start talking about parallel lines, if you think about parallel lines, they will never intersect. So we'll talk about they won't have any solutions in common. So that happens.
That's when we talk about systems of equations.
Right, when we get into systems. So you'll see it again at that point.
So now we're solving like single linear
Right.
equations.
Right. So usually, most of the time, when you're solving linear equations, you're going to get a solution, but we have to show you the times that it doesn't happen, because that does. That's true too. Okay. I feel like not everybody has asked any questions, but I hope that you feel like you can. If you need to go over any others, I'd be happy to do that. So if there are no other questions, or if you feel like you want to ask after class today, that's fine too. But what I'm going to do is just jump over to the little review, that I posted for you guys, and we can just kind of go through what we learned this week and what you should know going into next week. And Matthew's posted the video from Monday, so you should definitely watch that before you come to class on Monday. Let's see here. So this again is just what we did yesterday on domain and range, and is it a function or not a function? And actually on number 4, I somehow did 2 graphs in one. So number 4, I really just wanted just the points, not that Big Dipper looking thing. So that's just practice on that. Now this, I would definitely recommend that y'all look at number 8, because that's where you were missing on this last test. A lot of you were missing signs. So that will give you good practice on can you do problems that involve negatives. That will show you if you can. Matthew, when y'all did rates of change, did you do like a table with, I forget what we did on that. I want to make sure that this is applicable.
I'm not sure what you're doing.
Can you see this right here?
Oh, no, we didn't do anything with a table.
Okay, so don't worry about that then. Don't worry about number 11. I couldn't remember. Then this is just, do you know slopes? Do you know if you're given a slope of a line, do you know what the parallel would be, what the perpendicular would be? And this gave you several problems to practice, different kinds of problems given 2 points.
But I think we do tables later, so it's probably not a bad thing for them to look at that.
Okay. Yeah, I just couldn't remember, sometimes we do things in different orders, and I couldn't remember.
I think when we get to exponential, we look at that and see if.
Oh, for sure, yeah.
Yeah.
But so I can just really quickly just show you what's happening here. If you look at a table and you see that these are my y values right here. If you take the difference, like 17 minus 22, you would get -5. And 12 minus 17, you would get -5. And 7 minus 12, you would get -5. And then these are my x values. If I took 2 minus -1, I would get 3. And if I took 5 minus 2, I would get 3. And I took 8 minus 5, I would get 3. So my rate of change, which is just another word for slope, would be the difference in the y, which is -5, over the difference in the x, which is 3. If that didn't happen when you did those differences, if you didn't come up with the same numbers here and the same numbers here, or they didn't reduce to the same ratio, then that would not be linear. But this is linear because the difference over the y's over the difference in the x's comes to that same ratio. So this would be linear. And then if you're asked to, so this is linear because there's a constant rate of change. Then it says if it's linear, express its equation in slope-intercept form. Well, we have a bunch of points here. We have the points -122, 217, 512, et cetera, et cetera. So you can pick any point that you want, any 2 points or any point that you want, and the slope. So I just pick like this one right here. Doesn't matter which one you pick, and you'd say y minus 22 equals -5/3 times x minus -1. And then you just go from there and solve it for y. So if you're given several points on a line and you're asked to write the equation, you can pick any point that you want. It's always nice if we give you the one with a 0 for the, if we give you the y-intercept, but we always do that. So then these, number 14 and 15, I'm hoping that you'll look and go, oh, like on this one, the X values are both the same. So what does that mean about the line? And on this one, the Y values are both the same. So what does that mean about the line? And then these are giving you a line that passes through a point and the slope. So you have to be able to know both intercept form and point slope form. And then also with parallel and perpendicular lines. That'll give you practice here. And then 19 is kind of challenging, I think, but it combines every single thing that we've done. So I think it's a good problem. Just looking at these, would you like to go, are you seeing some that you know for sure that you'd like to see how they're worked?
19.
Now you want to look, okay, let's look at 19. 19 is one that I like it because, like I said, I think it just kind of combines everything that we've done. So this is in 1998, an estimated 50,000 people in the US died from AIDS. By the year 2018, the number of deaths was down to 10,000. When a problem starts like this, I automatically start thinking, what have they just given me? They've told me that in 1998, there are 50,000, and I'm not going to write 50,000. You could if you wanted to. I'm just going to write 50, but just in my head, I'm going to remember that stands for 50,000. 50,000 people died from AIDS. And then the next point would be, what would be the next point in this problem?
2018.
2018 what?
10.
Yes. So I go, oh wow, I've got 2 points. Well, if I've got 2 points, what probably I'm gonna be asked to do with those 2 points is figure out a linear equation, almost always. So it says find and interpret the rate of change from 1998 to 2018. So that means you need to know what is a rate of change. What's another word for rate of change?
Slope, right?
Slope, exactly. So rate of change for a line is the slope. And the slope is going to be y2 minus y1 over x2 minus x1. Okay, so it's -2. All right, now think about when you're asked to interpret the slope, what was the numerator? What is the difference here representing in the numerator?
That would be a decrease in the slope.
It is decreased, but what I'm asking is, like, what is the 50 and the 10? What are they representing in this problem?
Sorry, you cut out there.
People.
People, right? The number of people, right? So the number of people with AIDS, right? And what is this down here? What is this standing for?
Years.
The years, right? So what this is -2, and again, I said in my head I have to remember the 1,000, right? So this means that every year from 1998, what's happening with the number of cases of AIDS?
Goes down by 2,000.
Right. So the number of cases of AIDS, however you want to say this, decreases by 2,000 per year, right? So that's what we're interpreting the slope. Then they ask us to write a function, a linear function for the number of thousands of deaths in a year, f of x, or we could just say y if you want to, but since we've started talking about function notation, we could also say f of x. So we have these 2 points. We know the slope is -2. So what's the next step here? What equation would we start with to write our to put this into a linear form?
Would it be point slope?
Which is y minus y1 equals m times x minus x1. So you can pick either point you want. It doesn't matter which point you pick. You're going to come up with the same equation in the end. So I'm just going to pick the first one, 1998.50. Oh, and this is another thing. When I was grading homework, I didn't grade that many last night, but the mistakes I saw were this. When you distribute that negative, a lot of people they would distribute the 2, but they wouldn't distribute the negative. So this would be -2x plus, right? Because a negative times a negative is a positive. So watch that. So we're going to add 50 to both sides. And that would be the same thing as saying f of x, because y and f of x mean the same thing. So that would be the function that we're dealing with for part B. Then it says use the equation to estimate the number of deaths in 2020. So how would we do that?
We would just plug 2020 into the x1 coordinate, right?
That's right. Okay, so you get 6, but what is that 6 really?
1,000.
6 what?
6,000 people.
Yes. So that's why it's really important. I'm always like units, because if you just leave it at 6 what? So 6,000 people with AIDS, right? And then the last question is just a total rotation, and you could, it says, do you think this is a good model? Why or why not? So I really don't know where this data came from. I don't remember if I made it up or came from a book. So, but I would say so really there's no wrong answer unless, as long as you can justify it. It's like I would say something like, I think this is a pretty good model because I know that AIDS has been on the decline for many years, and something like that. But you could say, I think this is a terrible model because I personally, I know there's more than 6,000 people that have AIDS in the year 2020. So really
There's also other influencing factors that would also go on with that. Like whether the president botches an attempt at doing that. I'm reminded of like the whole Rock Hudson incident and like all that mess that happened with Reagan. Oh man. But
yeah. So really and truly, these kind of questions, like right here, where you're asked for an opinion, it is an opinion, but you just have to be able to say why you think that way.
That and the cures that came along since then. You're
Oh
gonna
my
see-
gosh.
Yeah, you're gonna see.
Yeah.
Certain,
Well, I was alive,
Wow.
guys, before anyone had ever heard about, AIDS. It was, yeah. So, I mean, this kind of question always kind of makes me sad because,
well, that and the initial. There's always like an initial, like very, very like large surge, and I think we're seeing it now too with the message going
COVID.
around.
Mm-hmm. Yep. So, yeah, for a while there, it looked like it was just there. It was so hopeless, but now, of course, it's much, much better. So, okay. Does anyone else see anything? Okay. So what I want to caution you on, whenever you're asked about parallel and perpendicular, like here, we give you the equation of a line for one reason only, and that is to find the slope. So like once you've found the slope using this line, then people get all confused. They go, now what do I do with that line? You don't do anything with it. Just throw it away. Don't even worry about it anymore. It's not even important to the problem. All you have to do is look at that thing, find the slope. So in this case, you would go, okay, 2y equals 4x plus 5. So that means y equals 2x plus 5 halves. The only part of this that's in the least bit important is the slope. So the slope of the original line is 2. And now you can just, know, you don't need to know. This is just out of the picture. And then once you know that, then you should be able to write the equation of the parallel and the perpendicular to the original line through a given point.
I think people have a really easy time doing the parallel because it's the same one. It's usually the
Right. It's the perpendicular that people get mixed up with. And so what is the perpendicular? So the slope of the parallel, I write it like this. Slope of the parallel would be what? What's the slope of the parallel? 2, right. What's the slope of the perpendicular?
-1/2.
Right. It has to be both flipped and the opposite sign. Good.
And it's a whole number, so they got to throw a 1 under there too.
That's right. So this is actually like 2 over 1, right? Anytime you have a whole number, it's like over 1. So on 14 and 15, remember, if you have a slope that is 0 slope, that's going to be a horizontal line. And it's going to be y equals to a constant. And when that happens, it's like that. You'll get m equals to 0 over some number. If you have the slope equals to some number over 0, that is no slope. And that is a vertical line. And that's going to be x equals to some constant. And when like number 3, you can definitely just go A, C, D, H, J, L, M, N, P, S for the names. And then the birthdays, I did like J5, J7, F24, however you want to abbreviate those is fine. On number 4, I would definitely list the points. then write the domain and the range. Definitely through for the day. If y'all want to leave, if you don't want to leave, then I will be here till 10 for sure. And
Is the next test gonna be everything up until the next test, or is it just gonna cover what came after the first test?
well, it's building blocks, right? But it mostly is after what's after the first test. Because you really have to know stuff from the first test to do what's on the second test. But
Sure, yeah, because it's a progression.
right. But it will be, yeah, it will be material starting with 3-1 and going through.
Yeah, it'll be focused on the recent material.
Right,
It's not
right.
cumulative. The only thing that's cumulative, like proper, is the final.
Okay.
And only half the final is cumulative. The other half is just another test, basically.
Right. And make sure you know how to do the lockdown browser. And well, I guess we'll practice that again, right, Matt? At the beginning. Yeah.
So I believe we're starting in what, 3.1 merit check? And then we work our way through merit check, and we're going to do like one chapter of Roxwald in this test.
Yeah.
I think I got the notes and put up the video yet, though. When's the test? Test should be next Thursday, I believe, right?
Yep, it's Thursday. And it's during class time. So make sure you know that too. It's not like you can just take it anytime during that day. It's from 9 to 10:30.
How many problems are gonna be on the third, other test? Next test.
I don't know. I hadn't made it yet. We'll let you know next week, early next week.
Yeah. And you know, the thing about those is even if we say it's 10, it's like there's built in, like we might have part A, part B, part C, part D, part F, you know, so.
It'll be about equally as long as the first test, probably.
Yeah.
We're trying to make them like, the appropriate length for the time.
Appropriate length and to where you have some time to go back and check your work and all that good stuff.
I think they're usually like 10 questions, but that's like.
Yeah, that's pretty standard. And we review on Wednesday. So I think y'all will be very well prepared for the test.
So I think the last thing we went over is functions. Yeah, and what Roxwald 1.4 is also more function stuff. So
And then we get into systems after that. Starts getting more fun.